Hello science students, Mrs. Kruger here. Today we are going to talk about electrons and we're going to learn how to build a two-dimensional model of an atom. So just some things I wanted to review with you before we start. We haven't covered the periodic table yet, but we will. So I've just printed out a very tiny periodic table on my computer. And we're working with lithium, which is an atom or an element that we've worked with quite a bit. So this is how lithium is represented on the periodic table of elements. Li is the symbol. This is the atomic number, which tells you the number of protons, 3, and also the number of electrons, 3, in one atom of the element lithium. And then this is the atomic mass, and hopefully you remember from previous lectures that the atomic mass is the number of protons plus the number of neutrons in an atom. So we have an atomic mass of 7. So 3 protons, 4 neutrons, and 3 electrons in one atom of lithium. Remember that the protons and the neutrons are in the center of the atom or the nucleus. Protons having a positive charge, neutrons being neutral, and then the electrons are on the outside of the nucleus. So we're going to talk about why we see this configuration today. So Niels Bohr was a physicist who came up with this model of the atom, and he imagined that the nucleus of the atom was like the sun and that the electrons orbited around the sun in these various energy levels. So he calls these energy levels. We know that this is not a very accurate depiction of the model. In fact, scientists use the electron cloud model today. You should have seen pictures of that in your slideshow. And the electron cloud model is more about making predictions about where electrons can exist. But Niels Bohr decided that each one of these levels were called energy levels. So he called this one energy level 1, energy level 2, and then if we had to draw more levels, it would be energy level 3, and so on. This is a really simplified model that is great to use for science classes and to draw examples of atoms. So that's why we're sticking with this model. I want you to imagine that the atom is like a hotel, and each one of these energy levels would be like different floors of the hotel. And I want you to imagine that each floor has a certain number of rooms. And those rooms can fit a certain number of people, so the people being electrons. So we can kind of use that to help guide our discussion. So in energy level 1, we can only fit one room. Each room can fit 2 people or 2 electrons. So that's why we have 2 electrons in this first energy level. Energy level 2 has more than one room. Energy level 2 actually has 4 rooms. So in each of those rooms, you can fit 2 people, which means energy level 2 can fit up to 8 electrons. I know this sounds kind of confusing, but I actually have a formula that we can use as we draw more models of the atom. So this is a nice little chart that you had in your slideshow that shows you how many rooms would fit on each floor of the hotel, and that it also shows you how many people or electrons can fit on each floor of the hotel. So energy level 1 would be floor 1, energy level 2 would be floor 2, energy level 3 is floor 3, and then energy level 4 is floor 4. On floor 1, there's only one room. On floor 2, there are 4 available rooms. On the 3rd floor, there are 9 rooms, and on the 4th floor, there are 16 rooms. You can fit 2 people per each room. So to figure out the number of people that can fit on each floor, or the number of electrons that can fit in each energy level, you would just multiply the number of rooms by 2. So there's a nice little formula that we can use. Physicists call the energy level N. So we can use the letter N to represent each one of these floors or each one of these energy levels. The number of rooms, which is actually called orbitals, so each one of these energy levels is separated into different orbitals. You don't really need to know about that right now, but it's helpful in understanding this idea. So each one of these rooms or orbitals, to figure out how many rooms can fit on each floor, there's a simple little mathematical formula we can apply here. So how do we get from 1 to 1? How do we get from 2 to 4? From 3 to 9? From 4 to 16? There's a pattern. So the number of rooms that are on each floor is just n squared. And hopefully you were able to see that, right? 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. And 4 times 4 is 16. So then, in order to figure out how many people can fit on each floor, right? Or how many electrons can fit in each energy level, you're just taking this number and multiplying it by 2. So we're going to do n squared times 2. That's really the formula that you need to figure out how many electrons can fit on each energy level, or how many people can fit on each floor of the hotel. So we'll apply this formula to do a new example to help you out. All right, I'm going to erase my board here. And then we'll do another example. All right, so let's work with boron. Boron's a pretty simple element. So the symbol for boron is B. Its atomic number is 5, and it has an atomic mass of almost 11. It's 10.8111. So I'll draw this a little bit larger for you to see. It's boron, 5, and then, what did I say that was? 10.8111. So we're just going to round this up to 11. All right. So the very first thing we want to figure out, how many protons are in boron? Well, we know this is the atomic number, which tells you the number of protons and also tells you the number of electrons. To figure out the number of neutrons, again, you take the atomic mass, subtract the atomic number. So we know that there needs to be 6 neutrons in 1 atom of boron. So I'm going to draw my protons. 1, 2, 3, 4, 5. I'm going to draw at least an indication of my 6 neutrons. 1, 2, 3, 4, 5. I'll draw another one over here, 6. And then I need to figure out how to configure my electrons. So I'm going to draw the first floor of the hotel. All right, I'm going to go back to my chart here. On the first floor, I know that I can only fit 1 room. Each room can fit 2 people, right? So I know that I can only fit 2 electrons on the first floor of my hotel. So I'm going to go ahead and draw my first 2 electrons. 1, 2. But there's a problem because boron has 5 electrons. So how am I going to fit the rest of the electrons? Well, I need to draw a second energy level or a second floor to my hotel. So I'm going to go ahead and draw my second floor. And I'm going to refer back to my chart. So on the second floor, I know that there are 4 rooms or 4 orbitals, and each one of these rooms can fit 2 people. That means that I can fit up to 8 people on that second floor. So I could have just applied the formula. Energy level 2 is n squared, 2 times 2 is 4, and 4 times 2 is 8. So that gives me the 8 people that can fit on that second floor. I don't need 8 though. I only have 5 electrons in 1 atom of boron. I already have 2 here, so I only need to draw 3 more electrons. So I'm going to draw 1, 2, 3. So just to double check my math, I have my 5 protons, my 6 neutrons, and my 5 electrons. So I've completed my Bohr's model of boron. I'm going to go ahead and erase this and do one more example with you. At least one more. All right, I think I'll use M&Ms for this example. So I'm going to work with the element oxygen. Oxygen is O on the periodic table. It has an atomic number of 8 and an atomic mass of 5.999. I'm sorry, 15.999. So I'll draw my element card here. This is for oxygen. 8, 15.999, which I'm just going to round up to 16. All right, that calls for 8 protons. I'm looking at my atomic number again. 8 electrons. And then 16 minus 8 is 8 for 8 neutrons. That's a lot to draw. So I'm going to use M&Ms. I don't have purple M&Ms, but I do have brown ones. 2, 4, 6, 8. So this is just another way to represent this. So that is my 8 protons. I'm going to use green M&Ms for my neutrons, which I need 8, 2, 4, throw a couple in the middle, 6, 8. So I have my 8 protons, my 8 neutrons, and now I need 8 electrons. All right, going back to my chart. So the first floor of the hotel has 1 room. Each room can fit 2 people. So I can only fit 2 electrons on that first energy level. So I'll go ahead and draw my first floor of the hotel. And I'm going to put in my 2 electrons. But I'm not done because there are 8 electrons in 1 oxygen atom, right? So to figure out, again, without even looking at the chart, to figure out how many electrons I can fit onto that second level before it's completely full, I can apply this formula, n squared times 2. So n is energy level 2, right? So this is E1, first floor. This is E2, second floor. 2 times 2 is 4. 4 times 2 is 8. So I know that I can fit 8 electrons on that second energy level. So I'm going to go ahead. I don't need 8, right? I already have 2 here. So I'm going to put the other 6 electrons on that second energy level. 1, 2, 3, 4, 5, 6. So I'll double check my math. Do I have 8 neutrons? Yes. Do I have 8 protons? Yes. Do I have 8 electrons? So I have 2 on the first energy level. 1, 2, 3, 4, 5, 6 on the second energy level. 2 plus 6 is 8. So I have my 8 electrons. So I've completed my Bohr's model for oxygen. All right. Let's try one more. This time I'm not going to draw or use M&Ms for the protons and neutrons. I think I'll just probably write P equals and N equals just to abbreviate here and save some time. So I'm going to use the atom sodium. So sodium, Na in the periodic table, atomic number of 11, and the atomic mass of 22.990. All right, so draw my element card. You certainly don't have to do this every time unless it's helpful to you. It's okay if you just want to look at the periodic table. You don't have to write it out. I like writing it out. 22.990. So I'm going to round this up to 23. I know that my number of protons is 11 by looking at the atomic number. I know that my number of electrons is 11. And then 23 minus 11 is 12 for my neutrons. All right, so remember I said I wasn't going to write out all my protons, and I didn't feel like writing out all my neutrons or drawing out all my neutrons. So I'm just going to say P equals 11 for the center of my atom. N equals 12. And when you're drawing Bohr's models, especially for atoms that have a significant number of protons and neutrons, I'm totally fine with you just writing this out. You don't have to draw it out every time. This shows me that you understand that there are 11 protons and 12 neutrons. That works totally fine. All right, so we have 11 electrons. Maybe I will use M&Ms for my electrons. If I can, I don't have enough orange, so we'll just draw them out. All right, so my first energy level, floor 1. So if I'm applying this formula again, n squared times 2, I know that 1 times 1 is 1, times 2 is 2. I can only fit 2 electrons on this first energy level. 1, 2. Okay, I still need 9 more electrons. So I'm going to go ahead and draw my second floor. So we're on floor 2. So 2 squared times 2. 2 times 2 is 4. 4 times 2 is 8. If you're not sure, feel free to keep looking back at this chart so you have this available to you in the slideshow in Google Classroom. I can only fit 8 electrons on that second energy level. So only 8 people can fit on that second floor. I need 9 more. So what am I going to do? I'm going to draw 1, 2, 3, 4, 5, 6, 7, 8. I'm still short 1 electron. The only thing I can do is move up to the 3rd floor, right? I have to fit all my guests in my hotel. So I'm going to draw 1 more floor. All right, so on the 3rd floor, squared times 2. 3 times 3 is 9. 9 times 2 is 18. If I look back onto this chart, 3rd floor of the hotel has 9 available rooms. Each room can fit 2 people. I can fit up to 18 people on that 3rd floor. Do I need 18 people? No. I only need 1 more electron to fill my 11 electrons, right? So I already have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I just need 1 more. So I'm going to draw 1 electron. Just double check my math. 11 protons, 12 neutrons, and then I have my 11 electrons. 2 in the first shell. I have 8 in the second shell. And 1 in the 3rd shell. I can fit up to 18, so that's totally fine. As you move up the periodic table and you look at atoms that have higher numbers of electrons, you would have to build on this model and add more shells. Remembering that you can only fit so many electrons on each energy level. You can draw any atom on the periodic table as long as you apply this formula, n squared times 2. Remembering that n is just the energy level that you're working with. So try drawing some Bohr's models of your own. You can use things around your house. You can use M&Ms. You can draw Bohr's models on paper. And I will definitely give you some examples to work with next week. So some digital online interactive examples where you can get some practice making models of atoms on your own. Please let me know if you have any questions, and good luck drawing your Bohr's models. Bye everyone.